tumbleweed. Cricket?
What is a vertical asymptote? Or when do they show up? When what happens?
Zero in the denominator.
Thank you, Nathan. When you have a 0 in the denominator. Does anyone know why you're not supposed to divide by 0 though? Because of what? Well, close. Did I ever tell you my story from college? Did I ever tell you my story? So I was driving down the street in college, okay? And I'm in my car, and all of a sudden so I'm listening to the radio, and I decided to divide by 0. And so all of a sudden I hear something on my roof. And I'm like, what is that noise? And so I get out and take a look, and a man in an eagle costume jumped on top of my car. So I thought that was kind of weird. I'm like, what are you doing? And as I'm asking that, he drops an egg on top of my car. It rolled off eventually. But I said, like, what are you doing here? And the only thing he said was, I have something for you. And then I didn't really understand, so he must have thought I spoke Spanish, so he said, yo tengo algo para ti. That's how he says it on the Spanish channel. But I'm like, what is happening here? So then I realized I should never divide by 0 again. This is a terrible thing. Because if you do, that's why a giant man in an eagle costume is going to hop on top of your car. Does that make sense, guys? So whenever you have anything at all, and you divide by 0, you have anything divided by 0, Eagle Man's going to come. So, graphically, what your calculator is going to do, it's either going to cut it off, or it's going to draw on that line. You know what I'm saying? And it depends on what model you have. But what I'll do, if you're about to, I'm just going to let you know. Okay, the only way you know how. I'm just going to give you the heads up. What does this mean? It means you're about to divide by 0 and knock it off. Okay? So, these are some of the things that we just have to be aware of. So if you have a function, like there's a couple examples here we'll get to in a second. But if I have the function like 1 over x minus 2, what's the bad number? Yeah, if you plugged in a 2 into this function, that would be bad. Trust me. So, graphically what we do is we just put in a nice dashed line. Okay? So we don't graph there. But, let's take a look at this. As you go left and right, is this going to have any horizontal asymptotes? This function? As you go right, what's it going to approach? 0? Do we agree with that? Why did you say that, Marco? Oh yeah, the denominator is going to get a lot bigger than the numerator. So it was that case 3. Okay? What about as you go left? What about negative infinity? As you go all the way to the left? What's it going to approach? As that gets really, really big from the negative side. It's also going to approach 0. Does that make sense? And with those positive values, when x gets 100 to 1,000, you're going to approach 0 from the positive side. This direction. Does that make sense? Because, oh my goodness, I'm okay. A positive divided by a positive is going to be a positive value, only a very small positive number. From the left, this is going to be 1 divided by a negative a billion. So a positive divided by a negative is going to be a negative. Does that make sense? Only it's still going to be a ridiculously small negative value. So it's going to do something like that. Okay? So what we're going to do is try to figure out what this graph looks like just by sketching it. Well, let's not look at 2, but let's go just to the right of it. A number just slightly bigger than 2, like 2.00001. What's going to happen if you plug that in for x? Yeah, you get 0.0001 in the denominator. If you divide 1 divided by 0.0001, what's the output? A very large number. If you divide by a ridiculously small number, you're going to have a ridiculously big number. Okay? So what's going to happen is, as you get closer and closer, this thing's going to streak up, all the way up to positive infinity. Okay? What about from the other side? Well, if you put in 1.99999, what are you going to be left with? A negative really small number, right? A negative 0.0001. Positive divided by a really small negative number is going to give you a really big negative number. Does that make sense? But it still gives you direction, meaning you're going to streak, bam, down that way. Okay, guys? Does that make sense? So here's what this graph looks like, and that's why that vertical asymptote is formed. Is because you're dividing by not 0, but really small numbers. And when you divide by really small numbers, the output is really big. Okay? So if I ask you, what is the limit as x approaches 2, let's call this f of x, on this function from the left? From the left, what is the limit as x approaches 2? Negative infinity. What's the limit as x approaches 2 from the right? Yeah. What does that mean about the limit? Limit doesn't exist, okay? And that's going to be the same for like the 1 over x function. Only in this case, you can't put it at 0. So if I approach 0 from the right, it's streaking up. Just very small positive numbers. I divide by that, so it's going to be a very big positive number. From the left side, I'm putting in very small negative numbers. So if I divide by that, the output is a very big negative number. So you're going to get a graph like this. For this case, this is an interesting little bugger. 1 over x squared. So it's just like this 1 over x, only what's going to happen to those these negative inputs that you're going to put in? You're going to square them. Yeah, does that make sense? Before you flip the number, before you go 1 divided by that really small negative number, you're going to square it. Which means it's going to be a really, really small positive number now. And when you divide by that, it's going to streak up. Does that make sense why this graph looks like this? And why this one looks like that, you guys? Again, because you can't figure out, if you go right and left, you can't figure out the direction of where it's streaking toward. In this case, it's going to look like this. Does this have any horizontal asymptotes?
Yes.
Eric, what do you think? Horizontal asymptotes?
Yeah, it doesn't go to 0.
Yeah, as x approaches positive infinity, this function approaches.
0.
Yeah, as x approaches negative infinity, this function approaches 0. And what's interesting, you guys, there are functions where those are different values. Just like 2 to the x has a horizontal asymptote left, and it goes up as you go right. There are functions where those are different, just so you know. It doesn't have to be the same value. And a couple years ago on an AP test, they actually had to rescore it because of that fact. Because people were putting different things. Yeah. Now in this case, we were talking about this yesterday. The limit as x approaches 0 from the right is positive infinity. You're right. The limit as x approaches 0 from the left is also positive infinity. Now here's the case, maybe where you could say the limit doesn't exist. You also could say that since those limits are the same, you could say that the limit at 0 is positive infinity. And what that just tells you, again, it just tells you direction. It still doesn't exist, but it says, okay, they're both going up. Does that make sense? Both answers are valid. We talked about that briefly yesterday.